So if you have two fractions, you just multiply straight across the top. I'm even going to write the intermediate step, which is this, 4 times 14. You could also write it with parentheses, 3, 9, 4, 14. But then you have one fraction. And then you could like simplify further just because these are numbers, but we're not going to have to do that this time. I just wanted you to remember that when you multiply fractions, you're just multiplying across the top, multiplying across the bottom. And it works the same way when these aren't just numbers. If they are just expressions involving x, then you do the same exact thing. So I think what I want to show first so simplify, and what we are going to have is 3x plus 18 over 3x squared. Remember, you can't just cancel out these 3's because there's addition here. We can't just cancel out these 3's. We have to have a factored form in the top, where we're going to have that times x over x plus 6. So to relate this to what we just did, all I'm going to do first is change this to 3x plus 18 times an x and 3x squared. I'm just putting it in parentheses, x plus 6, and writing it as one fraction. I can't factor anything else. I mean, I could rewrite this x squared as x times x. Maybe I'll do that eventually. But I can't factor anything out of the x plus 6. I can factor out stuff from the 3x plus 18. I can factor out a 3, yes? So this on the side, I'm going to say 3x plus 18. Factor out a 3. And so I get 3 times x plus 6. So I have 3x plus 6, x, 3, x, x, a little multiplication, x plus 6. So far, any questions? Now this is as simple as we can get it, but again, we have to figure out the restrictions by setting the denominator equal to 0 and solving. So I would say 3 times x times x times x plus 6 equals 0. That means x is equal to 6 and 0. Those are the values that I cannot have in the denominator. I just get 0 twice because I have two pieces there. So these are the values that I cannot have for my restrictions. And then I'm going to cancel stuff out because our goal is to simplify. So the x plus 6 cancels with the x plus 6. That cancels to 1, but I don't have to write the 1 because I have a 3 in the top and an x. But let's see what happens. Cancel out one of the x's with another x. And since I said before you couldn't cancel out these 3's because of this plus, but now we just have 3 times a piece and then times another piece. So we can now cancel. So there's nothing left over in the top, so I do have to write 1. And then in the bottom, I have just an x. X not equal to 6 or 0. So all of that, you just write it as one fraction, figure out what the bottom cannot be, and then cancel. Actually, yes. This, if I set it, because I skipped that step, x plus 6 equals 0, I'd have to subtract 6, so that would have to be negative, which makes that negative. Good catch. Sorry about that. These have the same instructions. Simplify. The way that I'm going to do it is first put everything in parentheses and write it with one fraction, like one division bar. So this y to the fourth, yeah. 4x cubed y negative 6 x squared y squared 3xy to the fourth 10x to the fourth. For some people, I think it'll be easier to write out instead of x cubed, just x times x times x. I'm going to do all of that. In fact, these are all multiplication. So really what I'm going to try and do, I'm going to put the 4 and the negative 6 next to each other. And then x for the x cubed. And then maybe the y, x, y. If you just remember your exponent rules, you don't need to write out all of this. But I think this is easiest to see. And then I'll have the 3 and the 10. Single x, 1, 2, 3, 4. And 1, 2, 3, 4. You could just subtract the exponents, but this, I'm just showing you, this is an easy way to do it. It's not confusing. You don't have to remember an extra rule. I'm just going to start canceling stuff. These all cancel to 1, by the way. So I'm left with a single y in the bottom. And you could reduce if you wanted to right away. If that's comfortable for you, then do that. But we could also just multiply negative 24 times 1, because all of this cancels out to 1. But we don't have to write it, because we have a leftover. And then 30 on the bottom with a single y. And then reduce that. Divide by, what, 6? Divide by 6, divide by 6. And if we can do more, we'll do more. But we get negative 4 over 5 and y. We do. But that was from the original. Can we just look at the top and see what x and y are not allowed to equal? What numbers can you plug in to make the bottom equal to 0? If you plug in 1 for x, you're multiplying here, right?
0?
The only thing is 0 for both of them.
Cool.
So if you can just look at that, x not equal to 0, whoops, and y not equal to 0, because there's two variables down there. You can just look at each piece individually. The only way this could be 0 is if x is 0 or y is 0. The only way this can be 0 is if x is 0, so 0 and 0.